Hi everyone, and welcome to our live stream for our online course Hurricane Tracking with Satellite Data. Thank you all for joining us. I'm Ciara McGrath and I'm joined here today by Astrid Werkmeister. So some of you might recognize me from the videos you've seen going through the course. In reality, I work on a spacecraft, but today I'm going to be revisiting my journalist role and passing on some of your questions to Astrid, who's going to answer them for us today. Hi Astrid.
Hi Ciara. So basically we'll be answering some questions that we've seen, that I've seen mostly in the comments, and we'll also, we'll see if we're going to get some comments in the live stream, in the live chat, and you also get the chance to ask some questions about satellites and like a lot of space stuff, because we have Ciara here who has more knowledge than I do when it comes to all the space related stuff. But when it comes to the hurricanes, I'm your person. So I'm one of the leading educators on this MOOC course. Then we also have Rose, who can't be here with us today, and so all your questions, we're going to try to answer them. If we can't, we're going to be putting them up on the step files, on the steps later on. So do we want to start with the questions here?
Yeah, absolutely. So if you do have any questions as we're going through, please do put them on the live stream on YouTube. I'll be monitoring them and putting those questions to Astrid. But to get us started, we've got some questions from the MOOC all ready to go. So Astrid, let's start with an easy one.
Okay.
Can you tell us which are stronger, hurricanes or typhoons?
That's a very good question. So there's this misconception actually that hurricanes are stronger than typhoons, but it's actually the typhoons in the Pacific that seem to be more intense and also larger in size. So they have very strong wind fields, and they have, because of the size of the Pacific, much more time to grow when they're traveling westwards. So they become bigger, get more energy from the sea surface. And there have also been some studies. I don't have the sources here with me today, but there have been some statistical studies to prove that typhoons are actually stronger.
Wow, okay.
Yes.
Really interesting.
Thank you.
And you mentioned there that some of the typhoons move westwards. So that's something else we had a lot of questions about, is why do these storms move in certain directions? Can you talk a little bit about that?
Yes, this has actually to do with the overall circulation of the wind circulations of the globe. So when you look at this image here now, you see that we have this zone of trades, which are basically cells that, wait a second, no, here. So you have here these cells that are called, around the equator, are the Hadley cells. Then those at the poles are the polar cells. And in between the Hadley and polar cells, you have the mid-latitude cells. So, and it is basically at the equator that the intensity of the sunlight is the strongest, and therefore there's most of the energy that is put into the atmosphere is rising, as you can see here between these two cells, and they are transported upward. So the energy is transported upward and towards the north or the south, where they're going to be descend again. This cell, the circulation that you see from the equator to about 30 degrees north or south, is the Hadley cell. And then from the, like on the poles, you have kind of like this, the opposite of this, well, it's the same kind of circulation, but it's from the poles, it goes towards the equator on the ground and backwards, so that you have descending air on the poles. That's it. You have descending air on the poles and uprising air at about 60 degrees north or south, depending on like where you are. And balancing, that's basically our entire system on the Earth, is like a huge balance system, is what is happening with the mid-latitude cells. So those are the reasons, like those are the circulations that are just going like upwards and towards the poles or away from the poles, and adding the westerly directions between the equator and about 30 degrees north or south is due to the Coriolis effect, or the Coriolis force. So because the Earth is turning, we have this force acting upon our Earth. It is largest towards at the poles and decreases with decreasing distance to the equator. So the closer you get to the equator, the less Coriolis force there is acting upon any package of air. That's what the scientists say. Then, so this Coriolis force basically acts upon like one package of air and is turned towards the east. So you see in like at the poles, it's the strongest, and that's why you see like these arrows going towards the east. Yes, east. I always have to check my directions. And balancing this out is basically at the equator, where you have all the trade winds going to the west. And it's because of this balancing between the wind directions on the entire globe, balancing of the Hadley cells, that you're going to have the cyclones moving westwards, closer to the equator, and the more they move north, they will be more influenced by the Coriolis effect, and therefore turn north, and then in the Atlantic head towards Europe sometimes. That's why in Scotland, where we are today, we're having like the remnants of some hurricanes. Long answer, I know.
Very interesting, though. Brilliant, thank you. We actually have a question from one of our viewers on the live stream here. But I actually think you might end up asking me this question, so we'll see, unless you have something to add. So from Matt Wyndham is asking about the International Charter on Space and Major Disasters. And does the work of the Charter affect spacecraft operations directly? And in the future, will it affect the design of spacecraft and constellations?
That's a very good question. And so there's actually a problem, kind of a problem that we're at Strathclyde are trying to address, and specifically Kira is trying to address. So I'm going to do like a little introduction, and then I'm going to give over to Kira. So the problem is that the satellites are in their orbit. They can't be moved. So when it comes to satellite imagery, we're basically waiting for a satellite to come over a specific area, for example, Haiti in our course here, And if there is no satellite that flies over that area, we have to wait until one does. And that's been kind of a problem in the past years, that we had to wait for like a long time that we actually get the ideal image that we want. And Kira is addressing that problem. So how would you want to solve this problem?
Yeah, great question. So yeah, as Astrid said, this is a problem that we have. Firstly, to say that the International Charter is a fantastic arrangement that helps us deal with this problem, because you can imagine that if every country, for example, had to have their own spacecraft to look at any disasters that were happening, then if they only had one spacecraft, the chance that it would be in the right place to take an image at the right time would be really low. And for countries like Haiti, for example, they might not be able to afford a spacecraft to monitor them. So the International Charter allows us to really quickly trade data between different countries who have different satellites available. And that means that we can respond to these disasters really, really quickly and basically work together globally to address them. So this is a really big step, and it's a fantastic initiative. But as Astrid said, it still doesn't always mean that we're going to have the right spacecraft in the right place at the right time. And so what a lot of people are doing is starting to launch more and more spacecraft to try and up the chances that there'll be a spacecraft where they need it, when they need it. What I'm doing here in my research at the University of Strathclyde is I'm looking at whether we can do more with less. So whether we can start to move our spacecraft to fly over different targets so that we can have a spacecraft overhead a disaster when we need it, instead of having to wait for one to come overhead. So it's still in the research phase, but this is what I'm really interested in looking at. But that's a fantastic question, so thank you for that.
Do we have more questions?
We do. So one of the other questions that I wanted to ask you, which
Yes.
I think is quite topical at the moment, is there a link that we're seeing between hurricanes and climate change? I think a lot of the students have noticed that there seems to be more extreme weather happening in recent years. And is this linked to climate change, or do we know?
So there have been some observations, and I brought you basically this wonderful graphic that is also shown in the MOOC itself, where you see the occurrence of the tropical cyclones, hurricanes, and major hurricanes over the past 100 years. We have data here in this graphic until about 2005 or 10. I'm not 100% sure, but that's approximately it. And it seems that specifically in the past 20-25 years, you see like this increase of all tropical storms, number of all tropical storms here in blue. Then also all hurricanes, and the number of major hurricanes is increasing over the past years. And there are also other statistical analysis that suggest that there is actually an increase over, has been an increase over the of the occurrence of Atlantic hurricanes. And there is a wonderful study that I found from Walsh et al. From 2016 about tropical cyclones and climate change. And what you see here in this graphic is basically, you see the entire globe here in blue. This is North America, where the pointer is, South America. In this area is the Pacific, and here the Atlantic. And the graphics that are shown here for each ocean where we have tropical cyclones occurring are showing these bar plots with percentage of change. Then the first plot shows all tropical cyclone frequency. The second bar shows category 4 to 5 tropical cyclone frequency. Lifetime maximum intensity and precipitation rate. So what we're looking at is basically in all graphics that we see here for each ocean is basically the first and second bar, and we're interested whether the blue line is below 0 or above 0, and then the second bar if like strong storms are above 0 or below 0. Above means there's going to be an increase, below that there is going to be a decrease. The light blue bar just indicates the possibility of error. So if we look here at the Atlantic, the North Atlantic, we see a decrease of tropical, like all tropical cyclones, a small decrease, but a large increase in category 4 to 5 tropical cyclones, just for the Atlantic. And this is approximately the same for all or most of the other areas. There's also a global, here in the middle of the charts below, a global change, and you see like they're expecting that the amount of all tropical cyclones is decreasing, whereas the amount of strong storms is probably going to increase.
So not necessarily good news then.
No.
So we had a little follow-up question about the charter and
yes.
some major disasters, asking about whether this influences how we actually design the spacecraft. So maybe things like their field of view, their resolution, the kind of instruments we use, the filters. So just to start on that, the first thing I would say is that the charter itself is really focused on an agreement between international parties and how we can trade data. And that's what the charter dictates. Having said that, there's always a desire when we're looking at disasters in particular to get the highest resolution data that we can. You can imagine if we want to look at somewhere like Haiti and see what the damage is after a hurricane, we want to be able to see roads and buildings as best we can. So we want those images to be as high resolution as possible. But there's always a balance. The higher the resolution, generally, the smaller the field of view, and so the less of an area we can see. So the advantage of the charter is that if we have more spacecraft available, and then we have more spacecraft available to see more areas, so we can reduce our field of view, get that higher resolution, and we can still make up for that smaller view by sharing our data with other spacecraft operators. But I don't know if there's anything you want to say about the type of, maybe the type of data we use to monitor these systems and the type of instruments.
So I am not aware of any new instruments that are going to be flown, but the regular instrumentation that is used so far are spectrometers that are observing the atmosphere in the visible and near infrared and infrared resolution with wavelengths with a ground resolution of about 500 to 1 kilometer. So that is for the geostationary satellites. Can be finer for polar orbiting satellites that are mostly used for weather observing systems. But an instrument that I find very fascinating to observe tropical cyclones in particular is the SAR, which is the synthetic aperture radar, which due to its frequency at the microwave wavelength can actually see through the clouds and to the top of the ocean surface. So it gives very nice insights to see just tropical cyclones, how they work and how they interact with the sea surface. But also for the disaster charter, it's interesting to for like damage observations yeah, so those are the main instruments for now. There can be, of course, more instruments coming up. You never know. Yes, so we are already like well equipped with instruments. Just like the biggest problem that I see is that like the satellites are stuck in their orbits, and if you want to get somewhere fast, or if you want like a high temporal, so high time resolution of an event, you're basically you're not independent. You depend on the satellite, and as a scientist, you want the highest resolution when it comes to time, to space. The more information you get, the better it is.
Brilliant. Thank you for that.
Thank you.
So we have one more question here, which I think you may have touched on already, but it's about why don't hurricanes occur in certain areas of the Earth? So I guess why do they form, where they do?
Yes, that's a very good question. So we have here this wonderful image of the past cyclone tracks, which I also posted on the MOOC. And here you see that particularly you see a lot of tracks here in the Atlantic. They're traveling eastwards and westwards and then eastwards. The same here in the Pacific, in the East Pacific, and also in the West Pacific, or Northwest, and here in the South, and here in the Indian Ocean. And one question that I also saw in the comments was, why is South America basically not affected at all? You see here it's kind of empty. And so the thing is that most cyclones are born in like in Africa, kind of like us humans. We're coming all from the same region. So you have these rainforests that are, due to their humidity, are kind of putting like a lot of energy already into the atmosphere. And as I said earlier, they're traveling towards the west, and it's around this area right here off the coast of Africa that the hurricanes start forming. Some of the hurricanes don't like dissipate within the Gulf, but the system itself travels over Mexico and continues to redevelop in the Pacific. So you have like these systems traveling a little bit overland and then are basically being reborn off the coast of Mexico. And then of course you have an area of further development in the mid-Pacific that are traveling westwards towards China or Philippines. And it's basically South America is not affected because of the Hadley cells and the Coriolis forces. When you look at the wind systems, you're gonna see like that the paths of these storms coincide with the global wind systems. And South America is kind of protected from that from these events, because there is not enough time and space or too much for the storms to develop and hit the coast.
Wow, fascinating. Very lucky for the people in South America.
Indeed, indeed.
So I think that's all our questions on the live stream just now. Just to let you know that we'll be finishing up in the next 5 or so minutes. So if you do have any last burning questions, get them in now. But otherwise, of course, you can still post them to the Future Learn Forum. Astrid, was there anything you wanted to finish on for the last few minutes?
I actually have a question for you.
Okay.
I do have a question for you, Chiara. So some of the students on the MOOC were asking about satellites, and they were like becoming smaller and smaller. Is this something you've observed in your career as well, or is it just like a myth?
No, absolutely. Great question. So satellites are absolutely becoming smaller and smaller. What we actually call it is we've called it sort of new space. And what we've seen is that over the last few decades, traditionally it was big companies who built spacecraft and launched them because it was so expensive to do. And what we've seen now is in the same way that our computers have gotten smaller and smaller and smaller, and now you can have in fact, the phones that we carry in our pockets have are more powerful than all of the equipment on the Apollo 11 mission that went to the moon. So you think about that all compressed in. Devices are getting smaller and smaller, and so we're able to pack more into a smaller space. And so what that means is that we can start to make satellites even smaller. And that means they're much cheaper to launch, because one of the biggest costs of building spacecraft is the cost of putting them into space on a rocket. That's one of the hardest bits. But the lighter they are, the easier it is to launch them and the cheaper it is to launch them. And so what's been amazing is not just that we can make these smaller, but that it means that smaller companies can start to build them. In fact, we have companies in Glasgow who have built over 100 spacecraft. We're building more spacecraft in Glasgow now than anywhere else in Europe, which is amazing. And these are all tiny, tiny spacecraft. So it's meant that we can start to do things like increase that temporal resolution Astrid was talking about. So if we have more spacecraft available, we can take pictures more quickly and more frequently. And that means that we can have more data available where and when we need it.
So kind of like a follow-up question I have. So if we have more satellites, even if they're smaller, isn't this kind of like, how you say, overcrowding space around us, and some of those satellites might not even be working anymore? Is there anything done with the debris that is left there?
Yeah, so that's a really great question. And I think it's really great that the students have noticed this and are getting concerned about our space environment in the same way that we're concerned about our environment here on Earth. So absolutely, the more spacecraft we launch, the more crowded space is going to get. Fortunately, now people are really becoming aware of this, and so we have charters in place that tell us how we can operate our spacecraft, and they advise us to launch to a low orbit where possible, so that these spacecraft will naturally burn up in the atmosphere once they're finished doing their job. So that's the first thing. But of course, there are still some spacecraft that we have to put in different places where they won't burn up later on. And there's still things from, back in the 60s and 70s, which are flying around up there, which we can't get rid of. So we now have companies, in fact, there's a company in the UK based in Surrey, who are starting to test ways of removing debris. So we've had things like nets and harpoons and all kinds of lasers and things being tested to see if we can find a way to send a spacecraft up, grab onto another old broken spacecraft and bring it down to Earth so it can burn up in the atmosphere. So it's definitely something that we need to be concerned about, but lots of companies are starting to look at it. But it's great that you guys are thinking about it too.
Excellent. So I think we're at the end now of our live event. I wanted to, before that, thank all of you for doing the MOOC and commenting on our steps. in such high numbers. And I personally love reading all your comments about like your own stories of having lived through hurricanes, also those who haven't, but are really thinking about how it would be and how you would be preparing for a hurricane that's coming. So thank you very much. I want to thank you, Kira, for being here. And yes, I think that's all from us today. You can watch this live stream on all our open channels. So see you soon.